Well, the day is finally here. It's we thought we had pushed it far enough for us to be organized, to be properly prepared for this. The day is here. It's 7th of May. Welcome everyone. I just want to try something out. ElixirConf Africa is happening in Africa. So if I'm not wrong, the most used language in Africa is Swahili. So I would like every one of us to, when I tell you so, to unmute your microphone and say hi to me in Swahili. Hi in Swahili is jambo. Okay? So if I tell you jambo, you respond back by telling me jambo. That's the simplest way. Okay? So feel free to unmute if you can. So let's go. Jambo.
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 Okay, that didn't go well. Let's try it once more. Okay, feel free to unmute. I hope you have the ability to unmute. You can also say jambo. I have a couple of colleagues here. So when I say jambo, just say jambo. Jambo.
Jambo.
Jambo.
Okay. All right. Thank you so much, everyone. I'll kick this off by doing a quick introduction on ElixirConf. So, jambo everyone, and welcome to this inaugural ElixirConf Africa. It's the year 2021. We are happy to have this, the annual conference, which brings about the BIM community in Africa and enthusiasts across the globe. Also, you're very much welcome. Welcome to the networking session. You'll be able to learn a lot. This is the first time we're doing this. You'll be able, we request that you forgive our mistakes. I'll start by explaining how all this started or was planned out. There's Elixir Africa, Elixir Kenya, which is a group of Kenyans who've come together who learn Elixir. Every week we meet and we do some mob programming on a few open source projects. That is when we come together to do that. We've done this for long enough. It's been about a year. So we decided to organize ElixirConf Africa. And in this, we reached out to other countries and they were very receptive. We have people from Nigeria, we have people from Uganda, we have a couple of people from South Africa who helped us organize this. ElixirConf Africa has been organized purely by a group of volunteers. We really appreciate you. We'll get enough time to know them later in the afternoon today. Welcome everyone. We hope you'll enjoy this session. We really appreciate this, the sponsors for this event who've made this event possible. And you'll get to know our sponsors. You're using the Hoover app for this particular event. The sponsor details are on the Hoover app, and we'll also give the sponsors enough time to speak about themselves. So today, we'll start by introducing our first sponsor, who is Carla. The colleague is seated right beside me. Welcome, everyone. Let me introduce the sponsor so you can take it over.
Hi, guys. So I wrote a speech with the help of my team. I'll just read it to you guys. Hopefully I do it well. So I'm from Kala and I'm the technical lead there. Yeah, thank you for the opportunity. So about Kala. Kala is a digital innovation company based in Nairobi, Kenya. Our mission is to catalyze Africa's digital future. We are a team of passionate and dedicated researchers, designers, software engineers, and data scientists, working together with companies, organizations, and even government agencies to co-create products, services, and new business models that solve key societal and economic problems within the African continent. My name is Mush. I'm the technical lead at Kala. I joined the company when it was founded at the beginning of 2020. And as the first member of the technology department, I helped put together the current team, as well as give direction on our technology stack. The choice to have Elixir as our primary backend language at Kala was driven by my passion for the language, having previously worked with Erlang and later pivoting to Elixir, and my understanding of the direction the company was taking in terms of product development. Our products and their requirements. The software products that we have built so far have been in the fintech, agriculture, health, and e-commerce industries. And from our experience, these systems that are meant to target mass market users require performant infrastructure to deliver a great user experience. As an early stage startup, It is important to keep our monthly cloud costs to a minimum while also providing the best possible service to our users. So why Elixir? Initially, as a team, we evaluated a number of backend languages and frameworks that could form. Initially, as a team, we evaluated a number of backend languages and frameworks that could form our technology stack, and Elixir ticked all of our boxes as per the requirements mentioned previously. As a language for server-side software systems, Elixir has many key benefits. For one, it is great for real-time applications due to its concurrency capabilities running on Beam, the Erlang virtual machine, which can run on any hardware. Elixir is also optimized for distributed decentralized platforms. It is battle-tested, considering it's built on 40-year-old Erlang. It is fault-tolerant, and it is easy to maintain due to its incredibly intuitive error handling. Examples of large systems taking advantage of this and other features of Elixir and Erlang include WhatsApp and Pinterest, just to name a few. The Elixir community is also very collaborative, welcoming, and support a wide range of projects in the Elixir ecosystem, which have easy-to-read and helpful documentation. Lastly, awesome libraries such as Mix, Ecto, and Phoenix allow our engineering team to be more productive. So far, we've used Elixir largely in building web platforms. However, we're excited about the direction Elixir is taking in terms of addressing the big data problems with projects like Broadway, and look forward to introducing the language to our data teams as platforms like NX continue to mature. Additionally, we're looking to explore IoT, and we are certain that Navs as a platform will be a great tool to experiment with when building products. We had a few challenges in adoption. One challenge we faced was communicating to our management team the value Elixir could bring to our software projects, why we should adopt it, as well as proving it could meet a large number of our requirements. Additionally, the talent pool in Kenya for Elixir engineers is not large, with the language only recently being picked up by the local developer community. So a brief word on how we've surmounted these challenges. At Kala, we promote a culture of learning and experimentation. As such, we have run training sessions for Elixir internally and continue to help each team member to improve on their language skills through pair programming sessions. As part of onboarding new team members, we have also added Elixir training to the process to ensure that we have a large team of Elixir engineers. I would like to give a vote of thanks and welcome you guys to the conference. We are grateful to the Kala senior leadership team for trusting us as engineers and allowing us to pick a novel language for use within the team. We're also grateful for their support in sponsoring this event. I would also like to laud the efforts of Beam Kenya in organizing this event. Kudos team. Our hard work has finally come to fruition. And in closing, a big thank you to all our distinguished speakers and sponsors for this year's event. Welcome to ElixirCon Africa 2021. Thank you, guys.
And without further ado, I would really, really like to introduce our first keynote of the day. So he is the creator of Elixir. I really wonder why we have to introduce him every time, because he is known by literally everyone. So he is the creator of Elixir, Chief Adoption Officer at Dashbeat. He is an author and also a really active member of the open source community. So without further ado, I would love to present to you Jose Valim. Jose, are you around?
Hello, I'm here. Good morning,
Hi.
Good afternoon, everyone. I hope you are having a great day.
Morning.
Okay, great. So I will start talking because I can talk without the slides. And then when I'm ready. Oh, it is ready, actually. This is fantastic. Perfect, thank you. Can everybody see like the full screen, the slide full screen?
Yes, thank you.
Beautiful. All right, so I'm going to be sharing Elixir updates, and then whatever extra time we have, we can use for answering questions and having a general discussion. I'll focus only on Elixir. I know like some people want to ask things about other work that we are doing with NX, Livebook, and so on. But the talk will focus on Elixir, and then we can expand later. All right, so let's get started. So the next Elixir release, which is going to come out in a week or two, is Elixir 1.12. we change our release cycles. Our release cycles before they were every July and every January, but we change it now to be every May and every November. So it's still a 6-month period, but we change it so we can align it with OTP. So whenever there is a new OTP release, we like a week later, we are going to have a release as well that uses all or the most important features in that OTP release to the best possible. So now they are aligned. That was our main motivation. So Elixir 1.12 is meant to be released in a week. Right now, we have 1,068 contributors in Elixir lifetime, Elixir history. And I always like to include some general information because it's always fun. So we are almost 13,000 packages on HexPM. And overall, we have crossed 4.4 billion of downloads. And what we are going to talk today, the main features we're going to explore today is the scripting improvements we have in Elixir 1.12, Erlang OTP 24 integration. As I said, the purpose was to align well with OTP. So the purpose of shifting the release schedule. So we're going to see what is new there. We're going to talk about stepped ranges. We are going to talk about some other general improvements, which I think are worth highlighting, and some community improvements, some improvements we did based on requests from the community or from some important open source projects. So let's get started. Scripting improvements. So Elixir, from the beginning, it was meant to be used as a scripting language, and we use Elixir scripts every day. So mix.exs file is a script, and it is a script because it doesn't write any bin file to disk. So it is a script. Our tests, they are scripts, right? We compile them, we load them in memory, but we never write a bin file to disk. But over the last months, as more people are starting to use Elixir, I started to hear some reports. Like people would say, Elixir has become like my main language. I really enjoy it, but whenever I have to write a script, I use something else. I use another language. So this was interesting because Elixir was meant to be used for scripting, but people were not using it. And then when I talked to them, or when I would read those discussions, they would point some main issues. So first one is lack of dependency management in a script. So in Elixir, we can, we have dependency management, but you need a project. You need to be inside a mix project, okay? And then you can list your dependencies. We can do that with scripts, right? So if our script needs to use any dependency, that becomes harder. Also, lack of conveniences to trap signals. So trap, if somebody do a Control-C or any sort of signal to stop the execution. There is no convenient way. It's possible, but it's not convenient. And also buffered I/O. So this is a property of the VM. Every time when the Erlang VM is running and you send some I/O to it on the default execution mode, the I/O is buffered. We are reading that I/O even if we never plan to use it. So I don't know if it ever happened to you, but like, so for example, if you do mix deps-get and then you are typing the next command that you want to run after the deps-get, that command is not there because the VM actually read it. So the VM is always buffering the I/O by default. That's why also you can't do like yes pipe to an Erlang VM because you're going to be reading the yes forever and then grow in memory. And we fixed 2 of those issues. Okay, we fixed the first 2 on Elixir 1.12. So the first one, the way we fixed the first one is by adding mix install. So now in your Elixir scripts, you can call mix install. And you can list the dependencies, and then it's going to get those dependencies for you. It's going to make sure they are installed, right? It's going to perform dependency resolution and make sure that everything is available, right? So it's worth talking about like why mix install. So many other languages, they have global packages, like you can have packages installed in your system, and we always avoided that. We never wanted to have global packages because global packages is always an issue, right? Because, maybe you have, you create a script that uses a global package and then you send it to somebody on another machine and then they cannot reproduce the exact same version, so that's not very convenient. Or maybe you upgrade your logo, maybe you update your local packages, or maybe you even, because those packages are global, you even forget where some modules or some file is coming from. So it's not good for reproducibility, right? It's maybe hard to reproduce the script, how to execute the script later. So we never wanted to have global packages, and I think so the idea with mix install is to have like a compromise between the project and the global packages. So you list the dependencies in the script still. Sure, if you just list JSON, it means that this dependency can upgrade at any time. But if you want to specify the exact requirements, you can do that too. So it gives you the ability to be as specific as you want, but still listing everything that script needs. The other change and the other benefit about mix install is that we have recently launched Livebook, and mix install is great. So Livebook is a collaborative code notebook, an interactive code notebook for Elixir. So you can write code and document the code, and it works great in Livebook exactly because we can now, in those code notebooks, you can also list your dependencies and exactly what is needed to make that code notebook work. The other feature that we added regarding to scripts is the addition of trap signal. So this is an example of how we are trapping the sig quit signal. So if you want to stop the VM execution, to print like, hey, I'm going to shut down. So I recommend checking out the system trap signal API for all information in what you can do. And just as an example, we started using trap signal in XUnit. So we added the feature and we already have a use case. So now if you are running the tests and, for example, your test gets stuck, you're like, which test got stuck? You don't know, right? Because you're not getting any feedback. The test got stuck. So you can wait, for example, 30 seconds until the default test timeout triggers. But now with the trap signal, if you send a control and the backslash, which is the sig quit, we are going to print exactly the tasks that were running at that moment. So it's going to help you pinpoint like one of those, because we run tasks concurrently. It can be many of them, but it's going to pinpoint which one are most likely stuck. And then you can continue with that information. All right. So those are scripting improvements. Next, Erlang OTP 24 integration. So Erlang OTP 24 is amazing. If you haven't tried out yet, the release candidates are out. And what is really amazing about, there are many features that are amazing. What is really amazing about it is the binge it. So, and you don't need to do anything to use the binge it. It even works with old Elixir versions. You just need to upgrade your Erlang OTP 24. And things are going to be faster. Compilation is going to be faster. It's amazing. But there are other features in Erlang OTP 24 that do require the Elixir team to catch up and add some improvements, okay? So there are some improvements to the compiler. And again, most of those improvements to the Erlang compiler, so it uses less memory, so it's faster. We don't need to do anything to use them, but some of them we had to do some improvements in Elixir in 1.12, so we can fully leverage them. Also improvements to code evaluation if you're using Erlang OTP 24 and Elixir 1.12, and you need to do a lot of code evaluation. It's going to be much faster depending on the code in Erlang OTP 24 with Elixir 1.12. So for example, when you do in Phoenix, when you run a generator like Gen HTML or Gen Live that generates a bunch of things, that uses code evaluation. It gets the template from disk and then evaluate them. And the test suite went from like a minute to 15 seconds when you bump the versions because of how fast code evaluation got, especially if you have large code snippets with a bunch of variables. We also got support for half floats on binary comprehensions, which we're going to talk about soon. And we also have the implementation of VP 54, which we're going to talk about as well. So half floats. So we have double precision floats, which are 64 bits. And that's the default double precision. So all the floats in the VM, they are 64 bits. And then we have single precision floats, and which are 32 bits. And then half floats, it's half precision floats, which are 16 bits. And although all the floats in the VM, they are 64 bits, you can serialize them in a binary with 32 or 16 bits. Okay. So how can we do that? So for example, imagine that we get pi right? Like we can serialize it as a double float or as a float or a half float using those three snippets right below. Okay, so you just say float and how many bits it's going to use to encode that, serialize that. And yeah, so so that's the addition. So basically, the last line is the addition. We can now do float 16. We can serialize them as 16 in 16 bits. And then you may wonder, okay, that sounds nice, but when would I ever want to use half floats? And half floats, you're going to use them when it's exactly, it's like when you expect. It's when you don't need all the precision, because if you have less bits, the floats, they're going to be less precise. So when you don't need all the precision and you want to save space, right? So you're trading accuracy for space. And the case when you do that is exactly, for example, when like graph cards, for example, if you need to send floats to a graphic card, maybe you're rendering something, maybe you don't need all of that precision in there, or some things related to numerical computing. So this is a very good addition that goes towards the effort that is happening on NX and things related to numerical computing in Elixir. And the other feature coming in Erlang OTP 24 that we had to do a very thin integration layer is called EP54. So, I'm sorry. So EEP stands for Erlang Enhancement Proposal. So that's how people write proposals to improve Erlang. And this particular EP is about extended error information. So this is code before we integrated EP54 in Elixir. Imagine that you create an ETS table and then you delete it. So if you delete the table, you cannot perform any operation on it. So then I call ETS insert on the deleted table, and I also pass an invalid second argument, because the second argument has to be a tuple, or it should be a list of tuples, and it's none of those. So in earlier OTP versions, what you would get, so this is Elixir running on an earlier OTP version, you would get something, say, argument error, right? But you don't know what is the argument error or which argument's wrong. And now with EP54, it's beautiful. It tells you exactly what went wrong. So it says, hey, we had an argument error, and it's going to tell you all of the argument errors that were wrong. So if all arguments are wrong, it's going to say something about all arguments. So it says, the table identifier does not refer to an existing ETS table. That's the error on the first argument. The second argument is not a tuple. So, oh my. So
That's you.
Thank you. So yeah, so now you have all the precise information. This is an amazing work done by the OTP team. So this is all the OTP team that did this. All we need to do is make sure we hook in the right places. And they started adding extended information to the standard library, to ETS module, to a bunch of modules, and they'll likely continue adding in the next releases too. The next feature in Elixir 1.12 is stepped ranges. And for us to talk about stepped ranges, why we need them, we need to understand the problem, okay? So here's a problem that I faced a couple times. So imagine that you need to generate a list of n random numbers between 0 and 1. So you're going to generate numbers that are between 0 and 1. And the size of the list is configurable. It's n. So if n is 3, you want it to return a list with 3 elements. But if n is 1, it should be a list of 1 element. And if n is 0, it should be an empty list. Okay, so you say, okay, sounds good. You go and say, I'm going to implement it with this code. You write this code, which is how I would personally first try to write it. And then you say, okay, I have a random list. I know that n needs to be more than or equal to 0. And now from 1 to n, okay, I want to call random uniform, and that's meant to return a list. So you write this code, and then you're going to test it, right? And then, okay, random list with 3, it returns a list of 3 elements. Random list with 1, it returns a list with 1 element. And random list 0, how many elements it's going to have in it? 2. Why 2, right? What is happening here? So so what is happening here is that 1, 2, 3. Okay, so remember we are building a range, right? 1 to n. So 1 to 3, it's the increasing range with 3 elements: 1, 1, 2, and 3. 1 to 1 is a single element range. But 1 to 0 is a decreasing range with 2 elements, 1 and 0. So in Elixir ranges, we look at the start and the end of the range, and then based on those values, you know if the range is going up and the range is going down. And while this can be very convenient, it has one big issue, is that we can't express empty ranges in Elixir. It's not possible. Okay, so we are going to address this problem by introducing stepped ranges. So if we look at this slide, 1.3, what is the step? The step is 1. We are always going up, right? And from 1 to 0, what is the step? The step is -1 because it's going down. Okay, so we are going to solve this problem by introducing stepped ranges. We want to make the step explicit. Okay, so we want to explicitly say, hey, this range is going up because the step is 1, or this range is going down because the step is -1. Instead of guessing, which is what we were doing before, instead of having this behavior being implicit, we are now going to be explicit about it. And now, so if I have with 1 to 3 with the step of 1, it's an increasing range with 3 elements. 1 to 1 with a step of 1 is the same. It's an increasing range with 1 element. And 1 to 0 with a step of 1 is an increasing range with 0 elements, right? Because we are already above the end, right? We can't go up anymore. We are already above it. So now we go back to the code and we explicitly add a step. It's going to solve the problem, right? Now when we say random list of 0, it's going to return us a empty list. So in stepped ranges, empty ranges are now possible. That's the most important part. But the step can be any number different than 0. So if you want now to have a range with a step of 2, you can do that. So for example, if you want to have a range that express the odd numbers, right, or even numbers, for example, you can do that. And in the futures, all ranges will have a default step of 1. We are going to remove this guessing behavior. Well, we have to deprecate it first, right? And then in the future, I mean, Elixir 2.0, because it cannot do breaking changes. So if ever comes out, maybe in a decade, right, we'll be able to swap the default, but the goal is to deprecate it. So if you're using Elixir 1.12 and you want to do decreasing ranges, go and be explicit about the step and the direction that you want. All right, and we also have some other general improvements in this release I want to talk about. So we have new kernel macros. So now we have tap and then as macros in kernel that allows you to do interesting things with pipelines. So in this pipeline, we start with the string hello world, and tap is going to execute the function that you give to tap, but it's going to ignore its return type. It's going to return the input. So tap IO puts is going to return hello world, right? So we just pipe into that, but ignore the result and we return the input. And then is a way so a lot of people, they want to use a pipeline and they don't want to pipe to the first argument, or they need to call something where they don't need to pipe the first argument, then makes it possible. Okay, with that now I can say, hey, I want to call this function, and in this function I'm going to pipe to this other thing. So those have been like very additions that have been requested for a long time. The issue of like how we pipe to something that is not the first argument, it has been discussed a lot. And sometimes people would even write code that I don't find. Well, we can see the example in the next slide. So if you look at the last line, so some people, in order to not pipe to the first argument, they would write the last line where they would find an anonymous function, they would wrap it in parentheses, and then they would call that, which for me, it's very unreadable. So our goal, so that code that we wrote here, it's the same as this code. Actually, there is a bug in here. I'm missing I'm missing this. It's the same as this code, but now I think it's much clearer with those two helper functions, step and then. And then the cool thing is that OTP24 now inline anonymous functions that are defined and then called immediately. So it's really great because if you're using OTP24 and Elixir 1.12 and you're using those new macros, there is literally no additional performance cost for using tap and then. So it's really convenient. Another improvement that is coming in Elixir 1.12, and this is in IX, so I think the easiest way to show it is to have some IX snippets. So we always had auto-completion in IX, right? So if you type like EN and then you hit tab, it's going to auto-complete the module in num, and then you can auto-complete the functions. And now the new feature is that if you auto-complete the function name, and then you add a space, or you add a parenthesis, and then you hit tab, we are going to show the signatures of that function. We are going to tell you what are the arguments of that function, the variable names. So it helps a lot for you to know what you should type in there. Really nice addition that was a contribution for the community. And another nice IX improvement in Elixir 1.12 is that before, for example, if you had a code that was a pipeline and you copy and paste that, you copy that code and you paste it on IX, it wouldn't work because IX would consider them to be incomplete expressions. But now when you paste a pipeline in IX, we know that, for example, you can see here that line. So I'm pasting the pipeline from the previous slide. So you can see that on line 2, we can see that you are piping. So it gets the result of the previous expression for you, and it works. Basically, the summary is you can now get a pipeline that spans multiple lines and paste on IX, and that's going to work. And this is a really nice addition as well. And then it's really cool is that it shows the result of each step in the pipeline. So, so it also helps with debugging and getting more information too. And finally, some community improvements. Those are features requested by the community that I think it's worth highlighting. So the first one is that Phoenix, there was just a pull request this week, and Phoenix Live View is introducing what they call Hicks templates, which are HTML plus EX. So imagine that you have HTML templates. Sorry, imagine that you have the usual EX templates, and those Hicks templates, they actually interpret the HTML in the template as well. So if you have tags that do not close properly, Elixir can tell you about it, right? So you're not sending fault template. So it's really the junction of HTML and EX, right? What would happen if your EX templates knew that they are HTML and how to use that information efficiently? And in order to do that, we had to do some improvements to the EX engine. So you can now receive text metadata. And it leads to great things like this that I think once the PR is merged in LiveView, a PR from Marlus, I think it's going to bring a lot of improvements to people working on LiveView applications and Phoenix as well. Another improvement that we did was a request or even pull request from the Absinthe folks. So in GraphQL, we have this idea of subscriptions. And in order to track the subscriptions, Absinthe uses the registry. And because you can have many subscriptions at the same time, that can take memory. So Absinthe added the option for the compressed option in the registry. So it used less memory. And we also added registry values. So certain lookups of data become much more efficient. So those are performance related features requested by and contributed by the Absinthe folks. And another addition in Elixir 1.12 is the code cursor context function. So the idea of the cursor context function is that you can give it some piece of code. Oh my! All right, you can give it some piece of code, and then Elixir is going to tell you what it thinks it is. It's going to say, "Hey, you are in the middle of a." I'm sorry. You are in the middle of the module name, or you are in the middle of the function name. Okay, it's going to tell you exactly what it is. And so, and tools like the IX autocomplete. So the IX autocompletion was rewritten to use this new function. And now you can see that tools like Livebook can use this function as well to provide autocompletion as you're typing Elixir code. All right, that's all I had to share for today. Those are my slides, my sneezes, and thank you for your patience and your attention.